Hey pre-calc, here we go with 2.2 solving quadratics. So again, these are some things you maybe have seen in the past. I'm going to do just kind of a overview of the three big methods to solving quadratic functions. Hopefully some of it will look familiar and some of it we need a little refresher on. All right, so the goal of solving a quadratic function, the goal here is finding your zeros or your roots. This pen just broke in half. Okay. The goal here is finding, and these are all synonyms, kind of. These are all the same thing. Finding the roots, finding the zeros, finding the x-intercepts, finding the solutions. Now, these are plural because a quadratic function, remember, can cross my x-axis at two different places. So sometimes you'll have two roots. Sometimes you will have two imaginary roots, which we will see today. Or sometimes you will have one root where your graph might look like that. All of these today are relating to an actual graph. Like what is it? Where is it? What is it looking like? Okay, so my first method here is factoring, solve by factoring. I would say this is definitely the quickest, but not all quadratic functions are factorable. So that makes it a little trickier. Okay, for example, let's say I give you this function in standard form. So x squared plus 11x plus 30 is equal to 0. Solve this. If it doesn't have the equal to 0, add it in. Solve this for x. What are the two values of x where it will be equal to 0? So factoring, remember, I'm thinking what two numbers multiply to 30 and add to 11. And I want to write this in factored form. So my next step will look like this in factored form. So I'm thinking like these two things, if I multiply them together, I'll get this as an answer. What two numbers multiply to 30, add to 11? If you need to, make a little list. What multiplies to 30? I like to go in order when I'm doing something like this. So 1 and 30, 2, 15, 3, 10, 5, and 6. Which one of these adds to 11? It's 5 and 6. So this is now in factored form. So you can kind of tell a lot from this function right now, like where my roots are, what my intercept is, things like that. But in order to solve, which is what we're doing today, I want to see what does x have to be, so my solution here will be 0. And since these two things are multiplying, either this one has to equal 0 or this one for the solution to be 0. Minus 5 minus 5, x is negative 5. Minus 6 minus 6, x is negative 6. Careful not to just like whatever this number is, flip it, because sometimes there will be a number in front of the x. So I just be careful not to just flip it automatically. Just take a look at the equation a little bit first. Here's a little spicier example. Let's say I have 2x squared plus 23x plus 45. A good thing to check here is if these are all divisible by 2, I could factor out that 2, factor out that a first, and then factor it like normal. But because these two are not divisible by 2, I can't do that here. My goal here, though, still is I want to get these in factored form. I want it to look like that. There are lots of different tricks to get there. I'm not super interested in teaching like tricks because they're not easily remembered. But I want you to think about with this one, it's what multiplied to 30 and added to 11. When I've got this 2 in here, it has to kind of be a part of that. So for this one, multiply the 2 and the 45. So what two things multiply to 90 and add to 23? So I really do it. I do them totally in order as much as I can. 1 and 90 until I come up with the answer. 2 and 45, that's 47. 3 and 30, that's 33. It's not divisible by 4. 5 and 18, that adds up to 23. So then once I get that, a couple different methods here. I kind of like the box method. Let's see, I might be going a little fast. So this is where, like if you were to multiply one factor and the other, this would be your solution. So 2x squared is going to go here. 45 will go there. And then these two numbers will be your x terms. 5x and 18x. Does not matter which one goes where at all. And then you're just going to kind of unmultiply it. So what can I divide both 18x and 2x squared by? 2 and x. What can I divide both 5 and 45 by? 5. One of your terms here is 2x plus 5. What can I divide both 2x squared and 5x by? Just x. And what can I divide both 18 and 45 by? 9. X plus 9. Once you're here, set these both equal to 0. Ugh. So 2x plus 5 is equal to 0, or x plus 9 is equal to 0. This one's going to be negative 9. And this one, though, this is what I'm talking about where you can't always just flip the second number because I need to divide everything by 2. So this means my two roots of this equation, or where it crosses the x-axis, are going to be at negative 5 halves, or negative 2.5, and negative 9. A lot of different methods here. I might do a second video of some more examples when a is not equal to 1. These do get a little tricky, but that'll be a separate optional video. So solving by factoring. Sometimes, like I said, quadratic functions are not factorable, so you can spend some real good quality time like thinking about the factors and then it not work. Also, I think sometimes this method, it just takes a long time to think of the factors sometimes. Like if it's a number like 90 or a number like 48 that has a lot of different options, especially if you've got some negative mixed in there. All right, next method is called complete the square. This would be how you move something from standard form to vertex form. And we'll just do one example from this one. Let's say I have x squared plus 8x plus 17. Solve for x. Find what x is equal to. Completing the square is all about making a perfect square here. A perfect square is where these two factors are the same. So you could write it like x plus 5 squared. Okay. Now, in order to factor to get a perfect square, I need this to be a perfect number. So this number should be whatever the answer is, the same two numbers, multiply to this and add to this. It's not going to be 17. So with complete the square, I'm going to start by getting rid of my c. And then I need to decide what my perfect c would be here. And how we're going to do that is I'll divide your b by 2 and then square it. So I want this to be 16. I want it to be 16. I just want it to be. Because the number that times itself, multiplies to 16, and adds to 8 is 4. So I want that number to be the same. I want this to be 16. In order to just randomly add 16 to one side, which is totally fine, I can just do it, as long as I also add it to the other side. So you can add anything you want as long as you do it to both. So then this is going to be x squared plus 8x plus 16. I can write this as x plus 4 times x plus 4. Because the two numbers that multiply to 16 and add to 4, it's 4 and 4 equals -1. Now, there's only one x in this situation. I need to solve for x. So next, what we're going to do is square root both sides. And that will cancel out my squared here. So x plus 4 equals, when I do this, it can either be a positive or a negative. And the square root of -1, if you type that into your calculator, you'll get an error because it's imaginary. X is not alone yet, so I'm just going to subtract 4 both sides. So your final answer here is -4 plus or minus I. So I still have two roots here, like -4 plus I and -4 minus I. There's still two roots because it's a quadratic function, but they're imaginary. They're imaginary. Okay. And the last method, this one will work every single time, no questions asked. Quadratic formula. But it's tedious. Formula. There's only one step, like plug in the numbers and simplify. But sometimes it's a little bit messy. Here's the formula. You'll never really have to memorize it, but I want you to know, have it nicely written down. And it goes with the song. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Hopefully this is something you have seen before. Here's your quadratic formula. And it kind of goes like this. So let's say I've got, for example, this random quadratic function that doesn't seem factorable. Let's go 2x squared minus 3x plus 7 equals 0. So I don't think there's anything that multiplies to 14 and adds to -3. I don't like doing complete the square when a is not equal to 1. You can do it. It's just more complicated. It's more complicated because the square root of 2 has to be involved there. So when I come up to something like this, I'm probably going to use the quadratic formula. A is 2, B is -3, and C is 7. The only step is to plug it in and simplify. So let's carefully plug these in. X equals -3, so that's 3, plus or minus the square root of negative 3 squared minus 4 times 2 times 7. I sing it to Pop Goes the Weasel. There's also a London Bridge version. All over 2 times 2. And let's simplify it. 3 plus or minus the square root of 9 minus 8 times 7 is 56. Ooh, this means we're going to get an imaginary number again. Divided by 4. 9 minus 56 is negative 47. Negative 47 all over 4. Only one really way to simplify this here. I can't leave this negative under the root, so I have to pull out the I here, the imaginary. So my final answer here would be 3 plus or minus I times the square root of 47 all over 4. See, quite yucky. So that would be quite difficult to do a complete the square with. So quadratic formula, I want you to always have it in your pocket, but know that often easier methods can be used.